And also, if we would just take a moment, you know, my dogs, they're getting their teeth cleaned today, and that means they're under anesthesia. I'm very uptight. I'm very nervous. I'm sure my babies are fine. And the other dog, the dog that's had the two torn ACLs, the money pit dog, she also has had her hernia fixed twice, and so we're fixing it for a third time. I don't know, y'all. This dog. You know how you have to check off, like, should we revive them? When I got to that one on her, I had to stop and think for a minute. Like, she is costing me more than my children. Anyway, all right, here we go. So, I'm going to talk about two different theorems today that we're going to use the synthetic. That's how we learn the synthetic divide. Okay. Shut your computer. There's nothing on your computer. Talk to you. You're shut all the way. Yeah, that's what I thought. All right. So we're going to talk about two theorems that we use the synthetic division for. So first of all, right here, if I wanted to factor this, we would do x minus 4 and x plus 2. We do x minus 4 and x plus 2. And that's because x times x gives me x squared. Then I get negative 4 plus 2x gives me minus 2x, and then minus 8. That's how we factor that. Then it asks, what are the solutions of that polynomial right here? So, first of all, what's the degree of the polynomial? 2. How many terms is it? 3. So that makes it a quadratic trinomial, right? So the solutions are when we take x minus 4 and set it equal to 0, and x plus 2 and we set it equal to 0. And that gives us our solution. So I get x equals 4 and x equals negative 2. And if you'll remember, that's the number that we tested when we synthetically divided yesterday. So that is a solution. And it asks, what do the solutions represent? Now, what do these solutions represent? This is a parabola. What are those two numbers? If I graphed it, what would those two numbers be? They would be x-intercepts. They'd be x-intercepts. What's another word for x-intercepts? Zeros is another word. There's two more. Does anybody remember the last one? Starts with R. Roots. So next it says substitute your solutions in for x and solve. So if I take 4 and I substitute it in where I see an x, if I substitute that in, 4 squared gives me 16. So 16 minus 8 is 8. Minus 8 is 0. So if I substitute f of negative 2, I'm going to get negative 2 squared minus 2 times negative 2 minus 8. So I get 4 plus 4 is 8. Minus 8 gives me 0. So what does that tell me? If I substitute in a solution, what do you think the answer is always going to be? 0. When we synthetic divided yesterday, if it was a factor, what did you get for a remainder? 0. Because anytime it's a factor and you synthetically divide, you get a 0. So that's, if you substitute the number in, you're always going to get a 0 back. So x minus r is a factor if f of r equals 0. So let's synthetically divide this. So first of all, is it in standard form? I have x to the third, to the second, to the first, and a constant. So it's standard form. So I'm going to write down the coefficients, 4, 6, minus 2, and 1. What's the solution I'm testing? -3, right? Because if I set that equal to 0, then I would be testing -3. You leave a little space, draw the line. This is where the remainder goes. We start by bringing down the 4. So -3 times 4 gives me -12. 6 minus 12 gives me -6. Now what? Multiply. So -3 times -6 gives me 18. -2 plus 18 gives me 16. -3 times 16 gives me -48. And that leaves me -47 here. So my first question is x plus 3 a factor? It's not, because if it's a factor, what would the remainder be? 0. But I'll tell you what that is. It is the y value. This point is on that graph. That point is on that graph. Because when you look at this is hard to factor, right? This isn't as easy as the quadratics. They're longer and they're harder. So instead of factoring, we use synthetic division to determine whether it's a factor or not. So what can we infer the answer in number 2 represents? It represents the y value of the point -3, -47. And that tells me if the polynomial is divided by x minus a, then the remainder is the y value. The remainder is the y value. Okay, so if you look at the top at the chart, it gives me a quadrat. It gives me a polynomial and a binomial, and then it asks me whether it is a factor or not. And if it is not a factor, tell me the remainder. So we're going to synthetically divide. So if you look at all of these, y'all, which one are we not going to do? Why am I crossing out 3x minus 1? How are we going to divide that one? Long division. So synthetic division cannot have a number in front of the x. Or it can, but it'll give you fractions. Okay. So if I'm doing x minus 1, what number am I actually going to test? I'm going to test 1. Is this in standard form? So we have 1, -2, -12, and 9. And we're not doing the bottom, so you can go ahead and write there. It's okay. So I'm going to bring down the 1. When I multiply, I get 1. And now what do? Add, multiply, and add. So what did you get for a remainder? So is it a factor? No. And the remainder is -4, which means the point 1, -4 is on the graph. Okay, so next let's try -3. Factor or non-factor? Yes, it is. Okay. Does anybody need me to keep going? Do you understand? Okay. You turn to the back. Put your name on it. Cross off the two that are 2x minus 1. And then complete this and rip it off, put your name on it, and turn it into